Notice the cover of this booklet has data at the center. Okay? Data is at the center. So we will collect data, right? It could be data or data. Okay? Height, scores on a test, that's big for teachers, right? The IQ scores, number of items, like maybe you're a store owner and you want to keep track of how many items you sell of certain brands that you carry, etc., right? It could be anything. What are we going to do with that data? We have to analyze it, okay? So one way that you have grown up, one thing that you've done in the younger grades, I hope at least, do you remember the mean, calculating the mean? Do you remember mean, median, mode? Right? Average, mean is the average, median, mode. So that's one way of analyzing it, but to be honest, it falls short. It doesn't quite do what we need it to do. So what we need to look at next is what's the dispersion, like what's the spread of my data, right? Is it spread out? Are they all kind of close together? Because let's face it, that actually makes a big difference, okay? Why am I saying that? Well, let's look at one very simple example, okay? Let's assume that these are your test scores. Your test number 1, you scored 0%. It was a bad day, right? Test 2, you scored 100%. What is your average? What's your average score on each test? Do you remember how to do average? The average would be 0 plus 100. What do we do with those two numbers? We divide it by 2 because you're adding two numbers. So that'd be 100 divided by 2 is 50%. Is that an accurate statement that on average, on any given day, when you come in and you roll in and you write your test, you get 50% on your test? I think it would not be a very good statement to make, because look, like you got 0 on one, you get 100 on the other. So we're going to look at that. We're going to look at data. If you collect a bunch of data, wait a minute, yeah, sure, the class's average is 80%, way to go, but maybe you just had a bunch of students scoring 100%, and everybody else maybe didn't do so well. Maybe there's a bunch of students that failed. So you need to look at your spread, okay? So that's what we're going to talk about as well. And that's where standard deviation comes in. This is new to you. I don't think anybody in here, maybe if you took some bio talks about stats, okay? You're going to see stats in bio, maybe grade 11, maybe grade 12. But you talk about standard deviation, okay? The symbol for standard deviation is this, okay? That's the symbol for standard deviation. The symbol for mean, if you go up here to where mean is, the symbol for mean is an X with a bar on top, okay? That's the symbol for mean. So if you see X bar, you're like, oh, finding average, okay? Finding the average. And then we're going to also, last but not least, I think visualizing, actually making graphs, is one of the best ways to actually be able to look at that and be like, whoa, wait a minute. This is very weirdly spread out here. Like, for instance, if I make a graph of test scores, 0 being here, 100 being here, and I graph them, and I see a bunch of bars like here, this is of course our 50, and I see like 1 bar in the 90s, I would be worried as a teacher. This is not spread out, right? This is a wide spread. You can write this down. This is very spread out. We would call, like, you have data on either extremes, okay? Not good. This is not good as a teacher. Why? Because some students really got it, but most students didn't. But if I did my math, my average may actually come out to be 70%, right? And so average alone means, in my opinion, means nothing. Like a teacher could come in here and after we do stats test and says, hey, my applied class got an 80 average, and I'm like, well, sorry, I got 70. But it's like, whoa, 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 let's dig a little deeper. Let's look at your spread. Let's look at what's happening. Like, did most students get it, right? Or not, okay? So last but not least, I like to have this on the cover so we can kind of know the end from the beginning, right? Sometimes it's better to know, like, where are we going from the very beginning so we know kind of what's happening, okay? So normal distribution is, you want to think of a bell curve. Think of a bell curve. So when we're looking at normal distribution, we kind of look at the center, the average, and let's go up, make a point right above the middle of this line, make a dot right there, and then just go down like this. The curve will flatten like this, and then you go back to the center and you do one of these. That's what we call the bell curve. Anybody remember when COVID started? Why did we have all the lockdowns and the vaccinations and all of that? What were we trying to do? Did you follow the news? We were trying to flatten the curve. Do you remember that? Am I talking gibberish here? Maybe you were too young. Maybe you were like, video games. Right? But we were trying to flatten the curve. We were trying to make the cases actually spread out. That's when we actually wanted the cases to be spread out. We didn't want everybody to get sick at the same time. Because if everybody gathered, if it's a hockey game, and then you have like 15,000 people in one building, guess what the hospital rate is going to go like, everybody's going to come in at the same time, and it's going to overwhelm the system. It comes right back to bell curve, okay? So sometimes spread out is good, sometimes spread out is not good, okay? So I'm not saying that spread out is necessarily bad. When it comes to tests, spread out is bad. When it comes to cases at a hospital, spread out is good, okay? So there we go. So this is the overview, bird's eye view of what we're doing, okay? Let's keep going. I know some of this is review, and good news is our calculators are gonna do most of the legwork on this. But it will also show you how to do it by hand, because university, they don't allow you to have a graphing calculator on stats courses, so I will show you how to do it by hand as well. You're gonna have to be comfortable doing it both ways, okay? So, the measure of central tendency, hold on, there we go. Let's make sure it's focused. So the measure of central tendency, I call it like so by the way, MCTs, if you see that, we're referring to mean, median, and mode. And they all try to find the measure of central tendency. That's what MCT stands for, okay? And so MCTs is trying to find a number around which the data clusters. Like which one of these, oftentimes it's all three of them, but sometimes it's only two or one. Okay, in mathematics, there are several ways to measure central tendency. The most common is the arithmetic mean. Okay, finding the mean, usually called an average in everyday language, right? You're finding the average. So here's the mean. It's got two symbols there. I use the X bar most often. It's denoted by the symbol X bar. It is found by adding all the values, then dividing by the sum of values. Make sure you include units when you calculate this. So here's your first formula that I would like you to add to your study sheet. Mean is, how do you say the sum of all numbers in math? This is it's the sigma, which some of you are going to like that one, right? Sigma x means add up all the values and then divide by the number of values, okay? And so this is add all, okay, values, and then we divide by the number of values. Okay, so that's your formula right there. That's the official formula of average, by the way. The median, use a different color for that one. The median is the middle value of a data set. It is most easily found if you have everything in ascending or descending order. In other words, sort it. Sort your list. Largest to smallest, smallest to largest, it doesn't matter. Okay? If there's an even number of values, then the median is the average of the two middle value numbers. Okay? Make sure you include units as well. So here, I'm going to give you a quick example. If you arrange your data and you have this, you have odd values, right? 5, you've got 5 of them. It's quite easily noticed that 5 is your median here. Because you have the same number of values to either side of it, so that's my median. So median would be 5 units. I don't have units right now. It could be minutes traveling to work, or walking to work, or bus ride, you name it. Okay. If you have even, so let's just have the same data set again, but this time I'm going to add another value to it. Here, you don't, right, this is even. 6 values, right? So you have to kind of find the two numbers that are in the middle. So it's between 5 and 11, right? Because you've got 2 on the left, 2 above it. So 2 below it, 2 above it. So you got to find the average. So the median is going to be 5 plus 11 divided by 2. You're essentially finding the average of the middle. That's 16 divided by 2. That is 8 units. So that's how things change, whether you're even or you are odd. Okay, next, our mode. You know what? I forgot to highlight that. I'm going to do that. If I ever ask you what does the median, like what's the definition or what does it tell us, this is what it actually tells us. Yes, it's the middle value, but at the same time it tells us that half of the time something will be below it, half of the time something will be above it. So the government, often when they release like tax reliefs or whatever, they'll say that a household with a median income of $60,000 will get like $300 back a year on taxes. You're like, what's median? If median is 60,000, means that half of Canadian families usually make less than that. Half of families make more than that, or households, I should say, instead of, right? So that's what median actually is, okay? So, mode. Do you know what mode is? Remember mode? It's the most popular, right? The number that occurs most often. And again, I say make sure you include units, right? You can have no mode, one mode, or a number of modes. Okay? So no mode if each number appears the same number of times. So I'll give you an example here. 3, 4, 5, 7, 9. Okay? Mode, none. Don't say 0, because if you say mode is 0, you're telling me that 0 is the most popular number. You just say none. Another example, 3, 3, 4, 4. I'm giving very simple examples here. I'm not spending. What if you had this? 3, 3, 4, 4, 7, 7. What's your mode here? Still none. How so? Isn't 3? There is no one single most popular number. They all appear the same number of times. Okay? So no mode still. One mode is if you have there you go. Your mode is 67 units. 67. Did you know if you've Googled 67, the whole screen will do this? Yeah? I didn't know that. But apparently that's a thing. Okay. Next, a number of modes. So let's take that. I'll do this. 2, 2, 2, 3, 3, 6, 7, 6, 7, 6, 7. Let's just go off of that one. This is like borderline no mode. Like if the 3 had appeared one more time, then every single number would have appeared 3 times, no mode, right? But because you have the 2s and the 6, 7, right, they appear 3 times. In this case, you actually have 2 modes. You have 2 modes here. So this one is borderline no mode, but instead it has 2 modes, okay? By the way, in this case, mode, okay, listen carefully to, mode would be a terrible measure of central tendency here. It would be terrible because it's actually grabbing both extremes on each end. There's no middle, right? You're trying to find the middle, terrible in this case, okay? In this case, mode is also not very good because it's grabbing the extreme on the upper end. Okay, so mode is not always a good indicator of central tendency. Okay, very, like, especially if you have outliers, it's not good. Note, although mode is referred to a measure of central tendency, okay, so for mode, what I want you to get out of this paragraph, it does not necessarily lie towards the center. Mode is used more often when a store owner, right? A store owner could use the mode to find out which size t-shirt is most popular. So you make a bigger order of that. Or the size of shoes, right? Certain sizes you have more of because you know you're going to sell more. That's where mode is better, but it's not a good measure of central tendency. Next, range. Range is not an MCT. It is calculated by subtracting the smallest from the largest. Okay. It is the measure of dispersion. So I'm going to highlight range. It is the measure of dispersion. How spread out is it? Tells us how spread out data points are. So I will give you this. Range is max minus the min. You have to be careful because sometimes the minimum could be a negative. So let's say temperature. In Manitoba, what's the range of temperatures? It can get as hot as 40 and as cold as minus 40, right? So what's 40 minus negative 40? The two negatives turn positive, so it'd be 80 degrees, right? 80 degrees difference. So you got to watch out. Make sure this minus stays there. And if this is negative, plug it in, and then the double negative will turn positive. More on that later. Last but not least is your outliers. Outlier or outliers. What are those? They are value or values that are significantly different than the general trend. Outliers can cause the mean to either increase or decrease. Outliers also affect the range of data. Okay, I will add something here that I want you to write down. Outliers skew the mean, okay? They skew the mean, they mess with it, okay? Use median if outliers are present. Okay. I would say use median if outliers are present. Then mean is no longer a good one. Okay. I'll give you a quick example. If we had Mark Scheifele in this room, he's a hockey player, right? One of our most famous Jets players. And we said, let's find the average income for this classroom. We would go around the rooms like, how much you make a month? How much you make a month? We'd all be like a couple $100, maybe a couple thousand. Some of you, I don't know if you're raking in that much. Mr. Dirksen, I'd be next, right? And then Mark Scheifele, couple $1 million a year. Let's do the average income. Let's do it. We add it all up and we divide it by what, 26, 27? Our average income would look really good, right? It would look really good because of the millions. That outlier in our data set has skewed the average. It's not really a good number to go off of. I couldn't go and announce in the announcements like, congratulations, applied grade 11, Mr. Dirksen applied grade 11 class, your average income is this high. You couldn't say that. It's skewed because of that outlier. So median is better. Median would be better because it wouldn't be affected by that outlier. More on that later. Let's go to 3. This is, in my opinion, brand new to you. This one right here is brand new to you. A very important page, nonetheless. Okay? What's going on there? Okay, so standard deviation. I have a whole page. You want to fold the corner of this page because you probably want to come back to this one quite often. So if you don't mind, you just fold that corner. If that bothers you, if it's like your OCD kicking in, don't do it. But it's probably a good one. Okay, standard deviation. That's the symbol right here. Sometimes I will call it SD for short, right? Standard deviation, it's lowercase sigma, okay? It's not uppercase sigma. So you gotta watch out for that. You're just a lowercase sigma, okay? I'm the uppercase sigma. Like you can tell that to your friends later. The standard deviation measures the dispersion or variation of data points around the mean. Put simply, here it is, standard deviation is the average distance from the mean of all the data points. This can be calculated and will have the same units as the data set, okay? We're looking for this when performing one variable stat calculations. Okay, more on that later. You don't need to worry about that one too much right now. But let's see what the standard deviation tells us. Can I give you a quick example? Maybe just pay attention. If you want to copy it, I want you to understand what we're doing here. If you go to the back, if you want to follow along, examples. This is way at the back. Let's say I'm just counting 5 students, right? 5 students got the following scores: 83, 84, 85, 85, 86. Okay? What is the average here? What is the average score? Let's figure out. Yeah, I wouldn't mind you writing this down because it's good practice already. 83 plus 84 plus 85 plus 85 plus 86, right? We'll add this all up. We divide it by 5 values. Okay. Let's figure out our average. I just made this up, so I have to do the same as, I'm in the same boat as you. 83, 84, 85, 85. Oops. I made a mistake. That doesn't happen very often, right? Okay, so it's 423 divided by 5. So my average is 84.6, which is about 85. Normally I don't want you to round, but in this case it's 85. Let's write down the scores. and the distance from the mean. So we've got 83, 84, 85, 85, 86. I'm copying these scores down in this table here. How far away is 83 from 85? How many units? 2. How many units is 84 from 85? Just 1. How many units is 85 away from 85? 0. 85 from 85? Still 0. 86, how many units away are we from 85? 1. This is not the standard deviation, okay? We're going to actually calculate that. But can you see that the average distance is not very far from the mean in this case? You see that? Okay. Data is close to mean. Therefore, clustered. Okay, they're clustered together. If we were to graph this, it would be clustered. Okay? Let's do another one real quick. If you're writing this down, I'll leave this for a bit. I'll do another one here, right here. Another example. Let's say I take a different class, not this class, but we have 60, 75, 85, 90, and 99. Can you figure out the average real quick for me? I'll just ask you to give me that number while I do my attendance. What is the average? Brave volunteer. Marie. 82? Exactly. 81.88. Okay, so that's, we're saying roughly 82, just for today's purposes. 82% average, is that what we have? Okay, thank you. So, scores, distance from mean. Okay, so we're gonna write them down, 60, 75, 85, 90, 99, okay? Oops, you can't see that because I'm trying to keep one finger on that page that I want to get back to. What's the distance from 60 to 82? That's about 22, right? 75 to 82, that's 7. 85 to 82, that's 3. 90 to 82 is 8. 99 to 82 is 17. No, that can't be, is it? Yes, 17. So do you see this? Can you tell that data is spread out? Farther from the mean. So I would say, I would call this, therefore, inconsistent. That's another way, another term you want to be using. We're inconsistent. There's inconsistency in this data set. Okay? So the average, can you follow my train of thought here? Are the averages astronomically different? Can you say, whoa, what happened? Like, look at the averages. 85 versus 82. There's not an astronomical difference. But when you dig deeper, sorry guys, some of you are copying this and I'm moving stuff on you. But if you dig deeper, if you look at the spread, that's where the problem is, right? That's where, as a teacher, you would want to look at that and be like, well, let's look at the spread on a consistent basis. Let's look at the spread. Is it coming closer together to where your average is, or is it getting further apart, right? Because that is a problem when it comes to marks. So that's what standard deviation is going to answer. Okay, I'm going back to page 3. Thank you for paying attention and following along. I appreciate that. So I'm going to use green for lower standard deviation because most of the time a lower standard deviation is better, right? A lower standard deviation generally indicates that the range will be low as well. Okay? How so, Mr. Erickson? Like, why can we say that? Well, look at the range. What is the range again? It's the difference between the max and the min. So the closer together the max and the min is, the smaller your range will be, which tells you that data is kind of clustered around the mean. Okay? Data points are closer to the mean. That's another thing you can say. You can also say that data is clustered around the mean. When it comes to describing the data itself, we could say that data is consistent. Okay? There are few or no outliers. Okay? If that usually, it means that there are few or no outliers. And the graph will show a steeper curve. Okay? I will do this for you here. What's happening here is our data is being compressed. Our data is being compressed to all be closer to the mean, right? On the other hand, if you have a higher standard deviation, let's go to this one right here. And I'm going to use orange for that. A higher standard deviation. So if you compare two different, like we'll compare basketball players, we'll compare, different data sets, and we'll look at their standard deviations. If there's a higher standard deviation, the range will be greater as well. Data points are going to be considered to be spread out widely. Data can also be called scattered further from the mean. Less consistent or inconsistent. Okay. There may be multiple outliers present, and it'll be a flatter curve. So what's happening here is your data is spread out, okay, and think of a water balloon. A water balloon. There's only so much water in that balloon. Like 100% of the water is in that balloon. Okay? And so if you were to squeeze the balloon, right, what would happen to the shape of it? It would actually lift up at the center, right? If you were to squeeze it from the sides. Similarly, if you had that water balloon and you were to squeeze it out, you were to spread the data that you have in there, it becomes flatter. So it's kind of like an air balloon or a water balloon, whatever you want to think of it. That's what we're talking about here. There's so much data. There's 100% of your data in that balloon. And so it could be spread, flatter, or it could be squeezed together, narrower. Okay. I'm going to stop here, and then we're going to do the math on a separate video.